All right, so as I mentioned before, we're going to talk about the D subshells and why they do that funny thing, right? So we don't see them until we get to period 4. And so when we're going across period 4, we would fill up 4s, then 3d, and then go back to 4 and fill up the P. So one thing I did not talk about previously was that the energy level, right? So the period or the energy level, those larger numbers that come out front, talk about how far away the electron is from the nucleus. So energy level 1 would be closest to the nucleus, energy level 2 is further away, energy level 3 is further away, and on and on. So it takes more energy to fill up those higher energy levels. So it's easier to put electrons in energy level number 1, but harder to put them in energy level number 2, and even harder to put them in energy level 3. This table down here at the bottom of this slide talks about that energy and the amount of energy required to put those electrons into those energy levels and subshells. So it ends up being much easier to put electrons into smaller subshells like S, and much harder, requiring more energy to put the electrons in the Ds, which are 10 electrons, or the Fs, which are 14. And so this chart down here in the bottom left-hand corner shows the energy, the amount of energy it required to put those electrons in. And honestly, I would not memorize this. Use this as a tool if this helps you to see why this is set up the way it is, but at no means do you have to memorize this at all. So energy level 1 or 1s has the absolute lowest energy. Next is 2s. And then 2p, which kind of correlates with everything we've been doing right along with the periodic table, right? Next in energy is 3s, and then 3p. And then we get to some funny stuff here with the 4s, 3d, and 4p. So 4s is right here. It turns out that it's going to be much easier to fill up 4s because it's smaller subshell than it is to fill up 3D. So 4s has a lower energy, then 3D, and then we go back to filling up 4p. So if this helps you, then use this. If it doesn't, and you're better off focusing on the periodic table, then go ahead and do that. All right, so I want to do an example so that you can see how we go through the D blocks or how we incorporate the D block when we are doing configuration. All right, so what I want to do here is I want to talk about chromium. So we are going to do the electron configuration for chromium. And so chromium here. And again, I want to start right from the beginning, right? I'm going to start in energy level 1. So I'm going to go all the way across and completely fill that up. So it is 1s2. Then I'm going to go to the next energy level or the next period. I'm going across the S block. So that takes me to 2s2. And all the way across the P block. And so that takes me to 2p6. Next, I am going to go down to energy level 3, period 3. I'm going to go straight through the S's, so that's 3s2. And then I'm going to go straight through the P's, so 3p6. Now I'm going to go down to period 4, energy level 4. I'm going straight through 4s. Right, so those two blocks, so that's 4s2. And now I get myself to chromium, and it is 1, 2, 3, 4 blocks into the Ds. And so this will be 3d4. You do definitely want to make sure that you write it out in the order that you went and filled it in. So I would absolutely write out 4s2 first and then 3d4. That would be the correct way to write this out. You are less likely to make a mistake if you do that. Don't go back and try to put the D. Don't do that. Don't try to put the D in front of the S. That's a bad idea. You're more likely to make a mistake that way if you do that. So go exactly the order that you went to fill that up. Okay, so here we're going to talk about the shorthand electron configuration. You are also going to potentially see this or hear this as the noble gas configuration or the noble gas notation. So the two elements that we're going to do the shorthand electron configuration for are going to be selenium and yttrium. Now, where is selenium? Here is selenium right here. Now, the reason why we are going to focus on this shorthand, and I'm going to actually do the longhand for selenium and then show you how to do the shorthand. If you were to do the configuration for something like lead, which sits right here at number 82, it would be really long to start with 1s2, 2s2, right? That would take you an awfully long time and a lot of ink to write that out. And in general, we're more concerned with the electrons that exist on the outside of the configuration. We'll talk about specifically what those are and what those tell us. So let's go ahead and we'll write out the full configuration for selenium. So again, we want to start all the way at the beginning, right? So we are going to go through 1s2. And then we're going to go through 2s. And then we're going to go through 2p. And then we're going to go through 3s. And then go through 3p. And then here we are, we're going to go through 4, oh, I forgot the 6, so 3p6. And we go through 4s. And we go through the D block, and remember that is 3D. And there are 10 electrons. And then we are 1, 2, 3, 4 spaces into the P. And that is going to be 4p6. That's not so bad, right? Or so horrible. But it would certainly be nice to be able to shorten this down so that there's a little bit less writing and so that we can focus our attention really where we want it to be. Now, remember in the previous slide, I had said, I didn't really make a big deal out of it, but I said these are full energy levels. What we have right here is the 1s, the 2s, or the energy level 1, energy level 2, energy level 3. Now you're going to argue with me on this because I've got 3d10. But that's full, right? And if I were to do the configuration for argon, I would say 1s2. 1s2. 2s2. 2p6. 3s2. 3p6. So rather than writing all of that out, rather than writing out 1s2, 2s2, 2p6, 3s2, 3p6, especially considering that those are full shells, and what we will find is that these full shells do not interact. They do not, those electrons, you want to think about them almost like being locked in place. Those electrons are never going to be involved in reactions or bonding. It's always going to be the electrons that are on the outside part that are going to be involved in that. So I'm just going to cross off my yttrium to give me a little bit more space. my shorthand noble gas configuration is going to be the following. I'm going to write argon in brackets, and that argon in brackets represents all of this. So my configuration is going to be argon in brackets followed by 4s2, 3d10, 4p6. Now in general, what I tell students to do, and we'll do yttrium next, is I tell students, and let me go ahead and erase everything that I have on the periodic table here. There we go. So we were interested in selenium. So what I tell students to do is I tell students to go ahead and look for the noble gas that ends the period before the element that you're working on is located in. So selenium is located in period 4. So I'm going to look to the previous period and see what noble gas completes that period. In this case, it's argon. So I would write that noble gas in brackets, and that represents the configuration up to that point. And then I would finish the configuration by focusing on the period that that element sits in. So let's do yttrium as an example. And I'll show you how this works. All right, so yttrium, let's write him over here, sits in period number 5. So what I want to do is I want to take a look at period, so if I'm in period 5, I want to take a look at the noble gas that ends period 4. And that is going to be krypton. So what I'm going to do here then is I'm going to write krypton in brackets. And what that is going to represent for me is the entire electron configuration up to krypton. So if I were to write that whole thing out, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. You can practice that by writing that out. But then I'm only interested in what's going on here, right? So I've written krypton in brackets, and then I go across 5s, so 5s2, and then I am one space into the d's, and remember the d's are one below the period that you're in, so this would be 4d, and I'm one space in, so it would be 4d1. There's a lot of practice with this in your guided practice. Make sure you do this and make sure you bring your questions to class.